Hello everyone. Today I will present my group project which is file recovery management and optimization system. In this file system simulator we have made how to recover a corrupt file and optimize the blocks, optimize the disk. In the extreme left side we can see how this is file manager where new file we can create new file, allocate random files, optimize files. We can also crash the system and recover the system. Below that, we have analytics of how the disk space is being used. We have total used space of 8 KB, and we have this much kind of space is free. We have 100% of the health of this disk. Now, in the middle part, we can see there are total 255 blocks, each blocks containing 4 KB of space, and the total is 1 MB. There are two pre uh, here we can see there are two pre-allocated blocks, each one containing f metadata, and these are called super blocks. In the extreme right, we can see their system call logs. After each operation, each system call will show here. Below that, we have metadata information like file system, block size, total block, free blocks, how many used blocks, how many damaged blocks, how many crashed files, and how many recovered and inodes. Below that, there are disk input output data where we can see how many bytes are being written and being read, how many system calls are invoked, and how many recoveries are being done. So let's say if we create a new file. So if I create a new file called sample.txt and allocate a 8 KB, 8 KB of a space, and let's create it. So now we have total 8 KB of a space, each blocks containing 4 KB. So we have two blocks allocate here. Now if we click on sample.txt, now we can also see how the system call logs are being shown here. If we create a block, then the system called open sample.txt and how it is being created. This is the system call log. And if I click on the system, then if I click on the file, then this log gets printed. Now let's put some data inside our file. I have used some lorem ipsum pre-built text. Now if I write on the data, we can see that block is filled with the data. Now here the system call logs write 1 buffer 1356. Here we have used 1356 bytes of data, and we wrote 1356 bytes of data into our sample.txt. For that, two blocks are allocated. We can also see how many writes are there, one write, and how many bytes are written. So 1.3 KB of the data are being written in the blocks. There are total 9 system calls till now have been logged. Now here we can also see the analytics of how many used space, how many free space, and what is the health of the disk. This is the disk name. And if I create a new file, another new file, let's say sample2.txt, and allocate only 4 KB of space. Now a sample2.txt is allocated on this place 95, and we have allocated only 4 KB of space. that is only one block is allocated. Now let's say if I write too much than the allocated space, like the text is using too much space than the allocated space, then automatically on writing the data, more blocks are allocated to this sample.txt. So if I click on write, here you can see more blocks being created. And in the system call log, we can see how much bytes of data being written. So total 5424 blocks of bytes of data written to sample.txt, sample2.txt. So let's say if I crash the disk or the system, if I crash the system, then this is the simulation how the files being corrupted or the disk has been crashed. Now if I click on sample.txt and try to read it, we can't read it, cannot read. This log says cannot read. Why? Because it's a damage block. Can we read sample2.txt? No, cannot read. So this means the blocks are being damaged and we need to recover it first before writing. So if I, let's say if I write on this file, we cannot write it also because the damage, we have to recover it first. In the disk IO, we can also see how many bytes of data are being read and how many crashed files are there. So two crashed files are there. Now let's say if I create a new file, another new file, let's say another file.txt and allot 16 KB of space. Now these many blocks have been created in our file. We can see damage block are 3, crashed file are 2. So now if I want to write in this file, we have written something in this file, another file.txt. We can read it. We can read it without any problem. Why? Because this file isn't crashed or corrupted. Now if I want to recover the system, we want to recover the system to read these many files. So on clicking on recover system, we can see here the recovery process is being done. Now if on recovery process completion, we can see the files being recovered and back to in use. Now we can read the file, read it. On recovery, here we can see these many system calls have been logged, have been invoked, the inodes being repaired, no need to remap, and the blocks being repaired. Now this was the recovery simulation. Now if I want to optimize it, then I will click on optimize it, and we can see all blocks are placed in a sequence manner to ease of access of these blocks, and we can easily read our files because these are defragmented in this space. Now in conclusion, this project helps visualize how file system works internally, especially how data is stored, corrupted and recovered efficiently. Thank you.